Am I audible, everyone? You guys able to hear me?
Yes, sir. Yes.
Yes,
Okay.
sir.
All right. Welcome you all in today's session. Just few seconds. Let's just start that. Let me share my screen, then we can start. So hold on, guys. I hope screen is visible along with me as well, right?
Yes, sir.
Yes.
Yes, sir.
Good.
Yes, sir.
All right. Very good evening to all. Good day to all. Let's just start the session. And today we are going to discuss more about that architecture, what we discussed in the last class. So we'll discuss what is the architecture we have in the, especially for the design point of view. And we'll try to understand two-tier architecture, three-tier architecture. We'll try to understand the leaf and spine architecture. What is the leaf and spine architectures? And how this leaf and spine architecture is going to be used, in which scenario it is going to be used, and how we are going to use the basically two-tier architecture and three-tier architecture. That's we'll do the deep dive today, and then after we'll see what next we can cover. But the basic agenda in CCNP ENCOR in the first module is to have the good understanding of the architecture. That's the basic concept. And once you guys have the good understanding of the architecture, probably we are good to proceed with the next step. Okay, so let's just start. Okay, before I start, anyone have any questions, guys? Or everyone good? Any question, please let me know. All right, so let's just start, right? So basically we have to understand, let me use the whiteboarding instead of the diagram and all. So I'll use a direct whiteboarding and then we'll understand step by step how the architecture is going to happen. So if I ask three-tier architecture, what kind of devices we are going to use in three-tier architecture? Anyone know that? In three-tier architecture, how and what devices are going to be used?
A router.
Two-tier versus three-tier architecture. What are devices are going to be in two-tier? Basically, in three-tier and two-tier architecture, are we going to use a switch or router?
Switches and routers.
Both.
Three-tier is routers.
Okay, this is the two-tier architecture and the three-tier architecture basically for LAN design or basically for the WAN design.
Two-tier is LAN and three-tier is WAN.
Three-tier is also LAN.
Yes, guys. So basically, if I talk about the two-tier and three-tier architecture, basically both are going to be your LAN infrastructure, not the WAN infrastructure. Means we are going to design the campus LAN. Means in this campus LAN, basically what is going to be happen? We require the switches. These switches are going to give the redundancy. Like just think about this way. So this is the like one layer. This can be known as your distribution layer and can be your core layer. Let me write it a distribution layer and can be the core layer. CL is the core layer. This is going to be access layer, right? So this design basically when you go for the LAN design in offices, small offices if you have, and I want to design the LAN, basically I can use the distribution layer or core layer and they are going to give the connectivity. I mean, this is going to give this connectivity like this one. So why we are doing this connectivity? Basically, we are doing this connectivity. The pen is not working for some reason. So basically, what is going to happen if I am going to make the connectivity in this particular distribution layer or core layer? In case of the any switch is going to fail for any region, right? So we have the redundancy. Let's suppose this is the one of the client connected on this switch. This PC is connected here, PC A. One more PC is connected here. That going to be PC B. So in both of scenario, where they want to go? They want to go on the internet. So definitely we have a WAN design as well. We require the WAN design as well. We require the WAN infrastructure where we have to connect the internet, and that internet connectivity require the routers. But we'll talk later how the WAN design is going to be happen. But initially we have to focus the LAN design. So in LAN design, if the traffic is going via this path, let's think about this path the traffic is going. to the internet. What is the possibility we have in the switching point of view? The switching point of view, the possibility can be this switch can be failed. If this switch can be failed, then what is going to be happen? Whatever the clients are connected on this switch, they all are going to be detached from network. And what kind of the clients can be there? On this access layer, we basically connect, like we can connect the access point, we can connect the PC, we can connect the laptops via the cable, we can connect the WLC as well, we can connect the printers. Generally in the small offices, we can connect the servers as well, some IoT devices, some CCTV. So these kind of the devices, these are known as the endpoint. Endpoint means basically the end user devices, which is going to connect on this particular switch. And these switches are going to be down in case of the any region, then probably we do not have the redundancy. What is going to be happen? In this situation, if there is a wire connections, if there is a wire connection, then we have to move the another switch. Means you have to get the, if a port are available, you have to move the cable on the another switch and you have to connect the devices. You guys are agree with me? Right? So this is the only way. If there is a wireless connectivity, so might be the chance if AP is going to be down where this is connected by this switch, another AP which is connected to the other switch, this is going to be still going to give the signals for the different area, but we are having the low signals ratio. Means we are not going to get very high signal ratio, and that is not going to give basically high quality of signals. So again we have the problem. So in case of the any switch failure, we are going to be trouble in the access layer where end devices are going to be connected. But if this switch is going to fail, let's suppose we do not have this kind of architecture. Let me design a different architecture. Hold on. Let's suppose I can design in this way. I can make the connectivity. I have a single switch here. This is known as, let's suppose, distribution switch, distribution layer. And just one switch I have, switch 1. Now this switch is connected with the that access layer 1 switch, AS1 switch and AS2 switch. Now we have the connectivity like this one. PC is connected. This PC is connected. Sometime we can make the connectivity within the AS switches as well. For some reason, if you have the connectivity, that is also possible. But ideally, we not require. Now in this design, what is going to be happen? In this design, if they want to go on the internet, if this switch is going to be down, whatever the clients connected on this switch, they all are going to be impacted. But only for this switch. But if this switch is going to be down, then what impact is going to happen? Anyone know? If this is going to be down, then what is going to happen?
Both S1 and S2 will be impacted.
So entire your LAN infrastructure is going to be impacted. So whatever the switch, I'm just showing the 2 switch, but might be have the 10 switch, and you have the 100 of the clients, might be the 500 of the clients, means they connected on the switches, servers, printers, they all are going to be impacted. So the layer you have to move, you have to think about redundancy, means how my network can be designed so I can get the better redundancy. For that, basically what we have to do that, we have to use the dual switch scenario, where my DS1 switch can be there and another DS2 switch can be there. DS2 can be there, right? They are going to connect this way, and they might be connected to each other as well, and they all having this kind of the connectivity, and might be we have the internet connectivity. So in case if this switch is going to be down for any reason, let's suppose I'm assuming this switch is going to be down for any reason, still this device can talk to the internet with this path. Make sense? If this switch is going to be down, still my device is going to talk to this path. If this switch is going to be down, so still if this switch is up, then still my traffic is going to be in this way. So this kind of design basically known as, when we have the distribution layer, sometimes this known as the core layer as well. Core layer. This is known as your basically 2-tier architecture. And this is also known as the collapse core architecture. If you are going the interview, might be they're going to ask, what is a collapse core architecture? Means collapse core means sometime what we have to do that, you don't have to use the distribution layer. You don't have to use the separate core layer, you just have to use only one layer. This layer basically act as a basically going to act as a basically a distribution layer and also core layer. This also going to act as a distribution layer and the core layer, and then they are going to make the connectivity with the your access layer, and this is going to be also as a access layer. This is also known as the collapse core architecture. So collapse core architectures and the two-tier architecture is going to be same. In both of scenario, we do not require any kind of the core layer of the design. So why basically two-tier? So two-tier is all about if you have this small network where you want to use your infra as a just minimum switches. You have the very less backbone capability. Means you not have to do a lot of kind of switching and all. Then you can use this kind of architecture. But if you have the very big offices, just think about the very big enterprise offices like think about the SCL, think about the Wipro, think about the Accenture, like that companies. So they have the multiple building, multiple floors. So they required the some core layer as well. So let me show you how the core layer and two-tier architecture is going to look like. So probably you guys are going to get some idea.
Sir, in two tier firewall would be
Yes, sir.
installed or not?
Go ahead, go ahead, please go ahead.
Sir, I mean, in two-tier firewall will be used or not?
See, firewall is totally different concept, okay? If you're talking about the firewall is going to play a different concept. Firewall can be used anywhere, even it's a two-tier architecture, three-tier architecture. Load balancer can be used anywhere. Either it's a two-tier architecture or three-tier architecture. So, if you talk about the firewall can be used. Clear?
Okay, sir.
But we are talking about the simple design like two-tier and three-tier fabric capability. Means if you have this kind of design, distribution and access layer, sometimes it can be the core layer as well. Then you are going to use the only two-tier architecture where my core is not going to be there. But when I talk about the three-tier architecture, then this is the three-tier architecture. You can see here. Means we have the access layer as well, we have the distribution layer as well, and we have the core layer as well. So now why this core layer is going to be important? In previous, let's suppose I want to use only two-tier architecture for my all network design. So what is the problem with that? Anyone have any idea? Let's suppose I can use the very high capacity switches and I just build the two layer of the architecture. What is the problem with that? Why basically we need the three-tier architecture? Any idea anyone have?
So
Idea,
redundancy
guys?
will be reduced.
Sorry?
Redundancy will be reduced, and bandwidth is also, मतलब कि सब्सक्राइबर जो हमें ऐड करने हैं, मतलब उस हिसाब से अगर मतलब जितने किसी कंपनी में कर रहे हैं तो रिडेंसी भी रिड्यूस होगी, और मल्टीपल नोड जो कनेक्ट होते हैं वो भी रिड्यूस होंगे, काउंट ऑफ नोड्स.
Yeah, that's partially correct. Anything else, guys? Anyone want to contribute? Why basically core layer is very important? Why not we can just always use the two-tier architecture? Core is basically known as the aggregation layer. You can think about this is the my architecture. In this architecture, what is going to happen? In this architecture, basically, we have the core layer, we have the distribution layer, and we have the access layer. But think about this can be your one building, and in that building, we have this kind of the layer, distributions, core, and the might be the access layer. But in the single campus, take an example of the SCL campus. In SCL campus, we have the multiple buildings and every building have the access layer. So in that access layer, we are going to connect the all like endpoints. Whatever the devices we have to connect there. But they need to terminate on the distribution layer. Why distribution layer? Because as building level, we have the one of the switch where it is going to be all aggregation is going to happen for the all connectivity. But if they want to go out from the network and they want to make the all connectivity through all the building, all the offices, then this is going to become a mandatory. You can think about this way. This is a distribution layer which is connecting to the multiple access layer. Then it's a core layer. Just think about this is the one building design. Now similarly, I have the another building. This is a building 2 design. So now I have to terminate all the aggregation to the core layer, and then core layer probably we have one of the diagram. Let me see here. Yeah. So this is the final diagram. You can see we have the multiple kind of department. Network services one department. Think about it. Internet WAN is one department. Data center connectivity one department. WAN edge connectivity one department, LAN edge connectivity one department. Similarly, we have the multiple kind of the buildings available in the same campus. So if I want to make them all connect together and exchange the routing through that interconnectivity between the different segment, then the core layer is going to be mandatory, because this is going to aggregate your all connectivity. Whatever the branches they have, might be they are coming from the WAN edge going to core layer. This is going to offload your all routing information to distribution layer. This is going to offload in this also means access layer, the VLAN based and MAC based communication is going to happen. But further, if you want to talk about the network services, if you want to go on the internet, you just have to go after core, then you go to the firewalls. Somebody was asking the firewall and all, and then it is going to take a filter, then it is going to the final internet, because filtering is also going to play a very vital role here. Make sense? So in 3-layer architecture, what is 3-tier architecture? We are going to use the campus core, right? This is a campus core. That is the distributions. The campus core is going to act as your aggregation of the different connectivity. And further, they are going to offload the routing informations and switching information, whatever going to be needed. And distribution is going to limit it to one building, one department, one particular segment. It could be your data centers, WAN edge, your internet segment, or could be any kind of the LAN building connectivity. And finally, your aggregation layer means the access layer is going to be your end point where all devices are going to connect. It makes sense? These 2-tier
Sir,
and 3-tier.
sir, in distribution layer, L3 switch is mandatory or not?
Yes, it could be or it could not be. Sometime it is going to require if you are going to do the routing. But generally in distribution layer, we apply the L3 switches only in distribution layer. But it's not mandatory. If you want to do the complete layer 2 communication, you can use the layer 2 fabric as well. There
अगर
is no
मैंने
problem.
इंटर विलन करना है वो तो मैं कोर स्विच में भी कर सकता हूँ.
Yes, you can do that on core switch. No problem. आप कर सकते हैं.
ओके.
तो सर ये एग्रीगेशन का जो है, एग्रीगेशन हमेशा कोर पे ही हमें इम्प्लाई करना पड़ेगा
आपने
क्या
नाम
सर?
बताना, एक बार एडमिन दिखा रहा है. व्हाट इज द नेम?
रुपेश सर, रुपेश.
अच्छा रुपेश, हाँ
हाँ
बताइए
जी
रुपेश, क्या पूछ रहे हैं आप?
सर, वो जो एग्रीगेशन है वो सर
हम्म.
हमेशा कोर लेयर पे ही काम करेगा?
ईवल एग्रीगेशन नहीं नहीं, ऐसा
हाँ.
नहीं है. मैं बोल रहा हूँ कि इफ वी हैव द स्मॉल ब्रांच, ठीक है ना, हमारा अगर छोटा ब्रांच है, वी कैन चेंज दिस एग्रीगेशन. ये पूरा एक्चुअली क्या होता है कि अगर आप इसको नहीं यूज करते, देन व्हाट इज गोइंग टू बी हैपन इफ यू आर नॉट गोइंग टू यूज दिस एग्रीगेशंस. सो ये जो स्विचेज आपके होते हैं ना, दिस स्विचेज आर गोइंग टू बेसिकली कनेक्ट. सम टाइम आपके सर्वर भी हम कनेक्ट कर सकते हैं, या हम एक्सेस पॉइंट भी कनेक्ट कर सकते हैं. तो कई बार ऐसा आपको मीन्स यू आर गोइंग टू फाइंड दैट कि डिस्ट्रीब्यूशन लेयर पे आपके कुछ सर्वर्स भी कनेक्टेड हैं. और यही आपके जो स्विचेज होते हैं, बेसिकली दे आर डूइंग द आल्सो एग्रीगेशन टू द कनेक्टिविटी. सो डिपेंड करता है, इफ यू हैव द स्मॉल ब्रांचेस, राइट, जहाँ पे 100 200 400 लोग काम कर रहे हैं, देन इट इज फाइन टू मेक दिस डिस्ट्रीब्यूशन लेयर ऑल्सो एज ए एग्रीगेशन, जहाँ पे आप मल्टीपल कनेक्टिविटी कर रहे हो. बट जहाँ पे आपको लार्ज स्केल, इफ यू हैव द ब्रांचेस एंड यू वांट टू मेक द कनेक्टिविटी, वहाँ पे आपको बेसिकली यू हैव टू यूज द कोर. सो इट्स ऑल अबाउट द साइज ऑफ योर नेटवर्क. If network is big, then you always have to go in the 3-tier architecture. If network is small, then you have to go with the 2-tier architecture. Let me show you something. Rupesh, इतना
Sir,
समझ में
I
आया
have one
आपको?
question.
यस
Yes,
सर,
yes, please.
WAN edge and internet edge, what is the difference between?
WAN edge and internet edge. So this can be your MPLS connectivity, okay?
Oh,
WAN
okay.
edge can be your MPLS. This can be your complete internet connectivity.
Internet,
This is
yes.
the only
Okay.
difference. Okay?
Yes,
If you
sir.
want
Thank
to
you.
make the lease line for the MPLS connectivity, so if I go here, let me just show you.
सर VRF also can be used
Coming.
switch to
Give me
switch.
one minute. One
Okay,
minute. I'm going to take.
So basically, we are using the core layer for high speed and a more reliable backbone.
Right. So see, if I talk about if I ask this question to the Google, right? It's not my version. What is difference between a 2-tier and 3-tier architecture? So 2-tier is simple for a small application where client directly access the database. Means it's a lot like Google-based wordings. But you think about if you have the small offices, right? You want to make the small connectivity where 300 500 users are there, you can use the 2-tier architecture. But when we have the large complex design connectivity, then you have to use the 3-tier architecture. That's simple definitions. Means 50, 100, 200, if you want to use the computer to make the communication, that's absolutely possible. But if you want to use the very high connectivity where you have to do routing, WAN internet connectivity, WAN MPLS connectivity, internet connectivity, data center connectivity, and all those are need to be aggregated, then you have to use the 3-tier architecture. So see, a small localized applications, direct connection between the machines and the database, but simple employee attendance system means this is just example application based, but this is going to be large base. So this is the basic difference between the 3-tier and 2-tier architecture. Okay, Rupesh, बताओ आप क्या पूछ रहे थे आप? VRF you were asking, right?
Yes, sir.
So देखो, VRF is something different. There is no relation here with the architecture with the VRF. Okay, VRF is basically known as the virtual routing forwarding. Anyone know what is a VRF? What is a VRF? Anyone know?
Virtual routing
Sir,
forwarding, sir.
That's the definition.
same route, physical router, we can divide multiple virtual router.
It is divide two or more routing table virtually.
तो देखो VRF हम आगे पढ़ेंगे, ये पढ़ता मैं बताता आपको. देखो VRF basically it's a virtualization technologies, and in this virtualization technology what is going to happen? Let's suppose you have one of the single router. This is router. How many routing table available in the one router?
One
Everyone agree?
global routing available.
Yes,
Okay.
sir.
So only one, that is known as the global.
Global routing table. Yes.
So VRF is a technology where you want to split this routing table into multiple routing table. Means you want to make in a single router, you want to make multiple routing table. So your hardware is going to be same, but one is definitely going to be global routing table. It's still going to remain. It's not going to remove. But you can make the VRF A, VRF B, VRF C, and VRF D. These all are going to be complete instance. Means one VRF cannot talk to another VRF. If you want to talk, it is not possible within the router. You want to make the communication, you have to use some interconnect. Means you have to exchange the routing via third devices, then only it is possible. How it is possible? Let's suppose this is a VRF is created, they want to talk, then you have to use another router here, and you connect this VRF on this interface, this VRF on this interface. These all routing is going in the global routing table, and via this global routing table, they are going to make the communication like this. So then it is only possible. Direct within the router, it is not possible. So VRF is totally different concept, Rupesh. There
Yes.
is no relation with
Actually,
your
सर जो मेरा डेटा सेंटर है ना उसमें उन्होंने वैन टू जो एक्सेस लेयर है वहां पे उन्होंने वीआरएफ कॉन्फ़िगर कर रखा है.
Okay, so I agree VRF can be there, right?
हम्म,
But VRF अभी हम बात करेंगे. It's a part of
जी.
course, ठीक है रुपेश?
ओके
So we'll
ओके
discuss
सर.
VRF कैसे काम होता है, कैसे configure होता है, VRF Lite क्या होता है, main VRF क्या होता है, what is different with that? So I'll cover later on. But let's focus on the architecture.
ओके सर.
ठीक है? Now we have to talk another type of architecture. Basically, that is known as the leaf and spine architecture. Anyone know what is a leaf and spine architecture? We understand tier 2 and tier 3. But what is a leaf and spine architecture? Anyone know?
Leaf can communicate with a spine, but a spine to a spine no any link.
Agree, sir.
Agree, right? And so what is difference between the leaf and spine architecture versus 2-tier or 3-tier architecture? Anyone have any idea?
Leaf span basically we use in ACI architecture.
ACI architecture.
Yes,
I'm
and
just searching.
T1, T2 is for legacy architecture.
Okay, okay, that's correct. Let me see. I should have one of the PPT. Leaf and spine, where it is. Okay, there should be. Give me 1 second. I should have one of the PPT here. Leaf and spine. Let me show you another good PPT. So you guys are going to find Good understanding. So basically, leaf in a spine is a tier 2 architecture or tier 3 architecture?
Tier 2.
Tier 2. Because we just have the one of the leaf, right? And one is the spine. So basically, what is going to happen if leaf and a spine are going to be connected? So spine is basically going to be act as your aggregation. So you can think in this way, right? This topology you can see. So in data centers, when you talk about the Catalyst 90,000 means 9,000 series, Cat 9,000 series we have, and also we have 9,500 series of that particular series of switches. They are going to use in the fabric where we are going to use the VXLAN, EVPN. If you are going to be learn the ACI, then these all are going to be covered. But in this architecture, what is going to happen? It's a two-tier architecture. There is no three-tier architecture. In this two-tier architecture, what is going to be happen? Spine is going to act as your brain, means like a core layer where all the upper links are going to be connected, means whatever you want to connect, it is going to connect in the upper layer. So everything is going to be connect on the your spine. And leaf is basically some one more good diagram should be there. Okay, this is the two-tier architecture, first tier two-tier architecture, and leaf is basically your all endpoints is going to be connected. Make sense? मतलब सारा जितना भी हमारा end device होता था two tier में हम करते थे, same चीज we are going to do here, but only the switches are going to be changed. And क्या switches use होंगे, that's also we have to understand. See, this is the like how the application server is going to east-west traffic is going to be there. So this is going to be your spine, and this is going to be a leaf, and this is the complete ACI solutions, right? And देखो यहाँ पे hardware component, because we have to know this kind of switches you can use. As I mentioned, 9,000 series of routers. So Nexus can be used in leaf and spine. 95,000 can use Nexus के Catalyst 9,000 series, we can use that. 93 we can use that. So basically this is the data center technologies, and you are going to find everywhere now within data center only leaf and spine architecture, where you're going to learn the eVPNs, VXLAN concept, how they're going to build a tunnel and all. So technically we are going to get a legacy two-tier architecture, that definitely for the small organizations, and three-tier architecture for the big organization is still going to be there. But if you are going to a data center, you are going to get two-tier architecture, and these two-tier architecture is going to build the your overlay underlay, and then they run the leaf and spine, and these all protocol going to be supported. Means if you are going to use this layer 3 and layer 2 architectures, means the leaf and spine, MPLS L2 VPN can be supported, VPLS can be supported, eVPN can be supported, VXLAN can be supported, L2 TP VT can be supported, Fabric path can be supported, ACI IVXLAN can be supported, LIPS protocol can be supported, GRE can be supported. So it's a very huge technology data center. And if you guys have a dream to become that data center engineer, so dedicated module is there, data center, where everything with the lab you are going to learn. But for time being, for architecture point of view, you should know what is a leaf in a spine architecture, and what is a two-tier architecture, what is a three-tier architecture, and what kind of model of switches is going to be used. So generally in the normal switching environment, in campus two-tier and three-tier architecture, generally what kind of switches we use? Anyone have any idea?
Nexus
Nexus is basically most of time you're going to find in the
data centers.
data centers. But in normally what we use? Any idea?
Catalyst.
Catalyst.
Catalyst we can find somewhere the 6545 is quite old, but still somewhere you're going to find that. Normally we are going to find the 37500, 36, 38500 switches, right? Okay. Now we have to understand one more concept. I forgot to mention that. Let me back that. Let me go on this particular whiteboard. Okay, so let's suppose we are having the one of the concept that is a stack switch. What is the stacking? Anyone know? What is the stacking? What is the
Two or
fundamental
more
of the stack?
physical switch. Two
Sorry?
or more physical switch connected with one switch. I mean, logically it will be one switch, but physically it could be two to eight switch
Okay, physically
using
can be
one
2 3 switches.
proprietary cable. Yeah.
So Mossad is saying something, and any other concept, guys? Anyone have about the stacking?
Stacking is a
No.
technology where two or more switches are connected in the rack physically, which can be operated as a single logical switch.
Okay, so
device.
basically what happened, we have the stackable switch, 3800 switch available, 3700 switch available. So in this, let's suppose this is my switch 1, right? This is my switch 2, right? And blah, blah, blah. We can do that. So basically we have the multiple switch, but these all switches can be work together. There is a stack cable is going to be there. This stack cable can be connected, right? Like this. So this is known as basically a stack cable. So what is going to happen when you're going to make the stack, means all switches are going to stack, means one by one, means the stack means this is the one switch, this is the another switch, this is the another switch. So this is the one stack, 1 2 3. This is the meaning of the stack, means one upon you put another devices to just make the stack. So basically what happened when you do the stack, how many control plane we have? Sorry.
One.
Control plane, and how many data plane we have?
And
Anyone?
data plane would be 3 and control plane would be 1, because controlling as a one switch for the all switch 1, switch 2, switch 3.
Master and slave
I'm just
concept.
asking simple answer. What is the difference between, means what is how many control plane is going to happen? One data plane is going to happen. First tell me what is a control plane? Can someone define what is a control plane? What is a control plane, guys?
Controlling the MAC table.
No. That's partially true. Yes, that's also intelligence is there.
Controlling the routing decision of the router in the
Routing
router.
means control is basically the brain, how to basically
Yes.
you decide to forward the packet, right? Again, I'm giving the example. Let's suppose I want to turn on the AC, right? So my brain say you need to turn on the AC. But to turn on the AC, what actually need to perform? My hand need to bring this remote and then I need to turn on the AC. Make sense? So actually, who did work? My hand did the work. But who gave the instruction? My brain gave the instruction. So control plane is my brain, but data plane is my hand. So in the switching world, if let's suppose any PC connected here, very basic example, and this PC A want to talk some other PC connected here, PC B. So before they connect, might be this is my gig 0 by 0 and this is also gig 0 by 0 port. So when they want to connect in the layer 2 environment, what is going to make the intelligence? Which table is going to be there in switching environment? How we make the communication? Routing or switching? MAC table or IP?
MAC table.
MAC table, right? So we have to take the MAC table. So MAC table need to be built, forwarding information need to be there, and based on that they are going to communicate. So there is a intelligence is going to build the table, and based on that table your data is going to forward from this port to this port. So actual data is going to be in or out from that interface, that is known as a data plane. Okay, so how many data plane we have in this particular architecture? 1 or 2 or 3?
3.
3, because the number of switches we have, that all is my data plane, but control plane sometimes known as a management plane also. So control plane means how we can log in with the switches. We can log in these switches. Basically, they are going to be different. They have the management IP address also. When they are going to be stack, right? But in the there are two concepts.
सर एक डिजाइन दिखाइए स्टैक का.
Sorry,
एक डिजाइन सर स्टैक का.
this is same design what I'm talking to. यही डिजाइन है, मैं बता रहा हूँ, रुक जाओ, ठीक है, रुक जाओ. This is the stack design. Now we have the VSS. Anyone know what is a VSS?
Same concept.
Sorry?
Same concept. Like
No,
stacking,
it's not
but
same concept.
virtual switch.
No same concept.
Okay.
Tell me what is the What is the VSS, guys? Basically virtual switching system, right?
Yes.
In this, what happened? We have switches like switch 1 and switch 2. In VSS, we can only make two switch together, right? We can only make two switch together, not more than two. But in the stack, we can make more than two, even we can go more than 5, say 7, 9, we can go that all switches are going to be stacked. What is the requirement of the VSS? What is the requirement of the basically stack basically only going to give the extra ports. Let's suppose if you have the requirement of 300 users are going to sit on the one floor in single floor, then generally by default each switch have the 96 port switch, right? 96 port switch, 96 port switch. So you need to add one more switch, then it is going to, let's 250 example. So these switches are going to give 250 ports if you're going to make in a stack. But in this case, every switches have their individual IP address to just log in and managing the cables. Means whatever the routing switching you want to do that, they just have the individual. So all control plane and all having a data plane. Means 3 control plane, 3 data plane. But if you talk about the VSS maximum you can just club 2 switch together, not more than 2 switch. And once you connect there, logically they are going to look one switch. If you go and log into switch for remotely, still they are going to give the lot of ports because they are going to use the modular switch, like basically the chassis based switch, 6500 switch, 4500, like right now you're not going to find in the industry. Some case you are going to find 6500, but 4500 completely end of life. So these are going to be logically become one switch, and based on that you can manage this switch remotely via the one single control plane or single IP address. There is no problem. But data plane is going to be 2. The one data plane for one switch, another data plane is another switch. But in this stack, you have the individual IP schema. Let me show you the differences so you can find that. Give me 1 second. So if you just type Cisco stack versus VSS, see here. So Cisco stack typically used to access layer. Basically, it is going to be defined in the access layer. But in the VSS, we go used in the core layer and sometime in the distribution layer as well. That is a key difference. Means the stack is going to give the only your number of ports are going to be there. These are the models. I told na 2900 switch, 37500 and 3850. This going to be 65, 45 and 68 nowadays it is going to be used. And in this case, what is going to happen? You can make the 2 switches virtually as a one. So they are going to act as a single control plane. But this is going to be make a stack up to how many switch? Stack can be maximum 9 switches going to be there. But in the VSS, only 2 switches is going to be there. So you can do the stack. Why you can do the stack? Because you have to take the number of ports. This also going to give the number of ports, but this is also having capability to process the high capacity traffic. And they also going to be process high speed ports capacity traffic. Means they have the fiber ports, they having some kind of the copper ports also, like 40 gig, 20 gig, 100 gig like of ports. You can see here high speed link is there, but this can be only 1 gig ports. And you can see some models are required to configure starting, and they can become the single logical unit. So you have to do the stack, then it is going to become the single logical unit, but still they have the all data plane difference. But this is also going to be virtual link is going to be there, and they are going to make the complete logical one control plane. But generally in every switch, even you can define the different IP address, it is possible in the stack you can log in the switches. But data plane is going to be differently together in VSS also and the stack also. And if you want to see that diagram, right? So Cisco stack, how it is going to look like? See, this is a stack diagram. You can see probably. So we have the switch 1, we have the switch 2, we have the switch 3, and we have the switch 3. And these are the stack cable. You can see one cable is going to connect here, Let me use the pen. And how this is very small stack cable. I cannot show you. I have a cables, but this is connecting on this one. This is connecting on this one. This is connecting on this one. So same way what diagram I make, and this was connecting to this one. This is going to make the stack. But if you go to VSS, stack clear na everyone? No doubt?
Yes, sir.
But if you go in the VSS, so what is in VSS? VSS is going to this kind of design. See, oh no, this one. You have the very high end switches, which is going to make the VSS connectivity like this. This is going to make a VSS, where you have the 10 gig circuit that's going to take the VSL link, but logically they are going to become one switch. If you see remotely, they are the just one switch. So this is the difference with the VSS and the stack, and these are going to deploy in the your any kind of the LAN infrastructure. I
सर
hope
एक
that one.
क्वेश्चन है
हाँ बताइए.
स्टैक में 3 कंट्रोल पैनल अलग अलग है, मतलब हमको अब जब मैनेज करना होगा 3 अलग अलग आईपी से एंटर करके मैनेज करना होगा।
Right.
तो हम स्टैक क्यों करें? हम तो ट्रांक भी तो कर सकते हैं ना, उसको ट्रांक पोर्ट करके 3 अलग अलग स्विच को कर सकते
There is a
हैं।
provision, even you can make the single management stacking circuit. We can do the single management also. Let me show you. Means there is a starting technique. We can make the stack switch can manage by single IP as well. Yes, see, because we have to do the stack cable. But basically what happened, even you want to log in the individual also, it is absolutely possible you can log in that. But once you enter the by a single IP address, you can switch the means एक switch से दूसरे switch में जाना है, तो you can easily switch from the switch to switch as well. That's also possible. So logically you have the single IP address, but even that single IP address, you can just switch the one switch to another switch, another switch to another switch, and you can do the configuration. But if you want to log in a specific any other switch, you can do that also, because it's also possible we can do that. Okay, Karthik?
Okay.
Alright, so now moving next, we have to understand the high availability technique. That's basically, what is the high availability? Anyone know? HA? What is the HA?
Redundancy.
Okay. What is the first thing we have in redundancy? Means before access layer, core layer, if device level redundancy, if you want to talk about, what is the device level redundancy? If I want to give the redundancy for my computer, then what is that? Any idea?
Sir, for computer by another computer only.
Means the computer want to talk on the internet. Let's suppose, let me draw another diagram. This is my access switch AS1. This is my AS2. This is connected by DS1. This is connected by DS2. This is connected with the CS1 and CS2. Okay. Now I have this client PC. Let's suppose this PC SVI is created on this particular core switch. The SVI is a switch virtual interface. Everyone know that's the VLAN interface. Okay, and let's suppose this is going to be 10.10.10.1/24. Okay, so what is challenge is going to happen? If let's suppose I created this SVI for any switch, there's two switch, and let's suppose for some reason the one IP I configure here on the VLAN, let's suppose this is going to VLAN 10 here, and this IP is going to be 10.10.10.2/24. Here is going to be might be the same VLAN. VLAN 10 here, and the IP is, let's suppose, 10.10.10.3/24 here. Now we have the upper layer, the WAN is connected. Think about this. This PC, let's suppose it's part of the VLAN 10 only, and this one having the IP 10.10.10.10/24. Okay. Now, if I want to go on the internet, the IP is required and the subnet mask is required. What is the one more mandatory thing?
Gateway.
Gateway. So every PC you need the gateway address, and this gateway either can be your this CS or can be that CS VLAN IP address, because it's a part of the VLAN one, and then after that they connected with the internet ISP. Just think about that. This is connected with the ISP. For some reason we have the link, so they have to go on the internet. So either they have to land in this gateway or this gateway. Let's suppose if I put the gateway of the 10.10.10.2, what is the problem in this design? Anyone?
Single point register. I mean, if
Code one switch is fail,
CS1
the
down,
total network is down.
Sir, if the gateway fails, the network was down.
So we have another switch, na? We told in previous discussion, if this switch is going to be down, another switch is going to be give the redundancy. We discussed, na? If this switch is going to be down, another is going to be redundancy. We talked about that. But how it is going to impact this client?
बट इसमें ये होगा कि अगर मल्टीपल पीसीस होंगे तो हमें मैनुअली जाके सब पे गेटवे चेंज करना पड़ेगा.
Yes.
Okay, that's the point, right? So always think about the client point of view. Whenever you want to design any client point of view, their gateway must be available. Their gateway must be available. And for that, we have the very important protocol, that is the FHRP, which is known as the First Hop Redundancy Protocol. First Hop Redundancy Protocol. And what is we have in this FHRP? 3 version we have, that is the HSRP, that is a VRRP, and that is a GLBP. We'll do lab later on, okay? Every lab will do later on. Don't worry. I will explain these all labs. What is the HSRP, how it is going to configure, how VRRP is going to configure, how GLBP is going to configure. But first understand these all 3 protocols. Out of these 3, your HSRP and GLBP is Cisco proprietary. VRRP is going to be open standard. Means any vendor can use that particular protocol. But GLBP and HSRP only work in the Cisco router. These protocols are going to give your gateway level redundancy. Means you do not have to assign the IP address, which is your interface IP address. This not need to be assigned. You not need to assign this one. You don't need to assign this one. If you are going to assign this one, if this router is going to be down, this switch is going to be down, you have to change all client PC IP address gateway manually. And your company might be having thousands of PC, 2000 PC, 500 PC. So it's not feasible for your IT engineer to go and change every engineer's like IP address manually, gateway address manually. So for that, I can use one of the concept, that is a virtual IP address, VIP. And this VIP can be used in the VRRP, can be used in the HSRP, and also can be used in the GLBP. Clear? This can be used any of the scenario. Make sense? So in that case, I need to give the virtual IP. Let's suppose I'm going to take a 10.10.10.1, and this IP never going to assign on any of the interface. No interface. This need to be created one of the VIP, and this VIP having the IP address. So what is going to happen if you making this switch as a primary switch? In this situation, always your traffic is going to hit here. But if this switch is going to down, this VIP is going to be associated with this switch, and your traffic will start sending by this way, and you go on the internet. This is known as the FHRP. That is the gateway level of redundancy. It is clear to everyone? यहाँ तक बात समझ में आई सबको?
yes sir.
कोई डाउट, कोई समस्या? Any problem till here, guys? All right. So this concept we have to do deep dive, and we have to understand later on how basically it is going to happen. Now one more concept we have to understand. Basically, it's also known as this FHRP. We discussed about the switch level redundancy, but we have to understand SSO. What is SSO, guys? Anyone have any idea what is SSO? Single sign-on? Any idea, guys? SSO is single sign-on or something else? I'm not able to find my PPT where it is. SSO is basically known as the stateful switchover. Okay, I should have some. Where is SSO? I should have one PPT. Give me 1 minute. Okay. So basically it's known as the stateful switchover. What is that stateful switchover? Anyone know? Have you heard, guys? Anyone in past? What is SSO? There is two terms. Basically, we have the SSO is basically known as a single sign-on. But this is not we are going to talk. This is not related to CCNP ENCOR. We are going to talk about stateful switchover. So what happened in the layer 3 switches and high-end router, we have the route processor. See, we are known as the route processor. RP is basically known as the route processor. So in case of any RP is going to fail for some reason, in case of any RP is going to fail, so device also have some kind of the redundancy, so that in case of any kind of the failure, your router is still going to do the traffic forwarding, routing forwarding, and that's the route processor. So basically you're going to see, let me show you, safe is going to be there, forwarding table is going to be there. So basically what happened, there is one diagram, let me show you, probably I can find that. Yeah, this is a configuration how can enable it. Generally required ASR router, high-end router, 4431 and 441 router. There is one diagram I am just searching, guys. So okay, so basically there is no, but you can see here stateful switchover. That is the meaning of only every router have the RP. RP is basically known as the automatic failover. If route processor of router is going to fail for some reason, if there is one router and the route processor is going to fail for any reason, then that router is going to be, this router having the RP1, route processor 1, and RP2. Even you can check in the CLI command also. If this is going to fail, then your non-stop forwarding is going to be stopped. Means you cannot make any routing decisions. So that's why when the router is going to design, if the hardware redundancy is going to there, and based on that, any fault is going to happen, your active RP need to be some reason going to be crash or reboot, the active RP not responding or dead, the standby RP is going to be automatically take the role and maintain the network operations. So that's the meaning of the RP, and this is the role of the SSO, which is known as the stateful switchovers, right? RP switchover. So this also you guys know, right? If you want to do the manually by CLI command, let me see. There is a configuration mode, go and the configure and configure the startup configuration, and you can just always run this command. So redundancy is going to give that basically how many RPs there, and based on that you can just check. Even you check the versions of the switch and router, and based on that also you can find that. So if you talk about on the Google also, you're going to find a similar kind of a definition. Cisco SSO stateful switchover concept. See, so in this basically what is going to happen, Cisco stateful switchover concept, a high availability feature for the device for the redundant processor, that is a route processor, nothing more than that. So by default दो प्रोसेसर आते हैं, एक is going to be active, another is going to be in passive mode, but in case of the active is going to fail, the standby is going to take a role and it is going to handling your all kind of the operation. Make sense? You guys understand the RP concept also? Any doubt till here? Come on, any doubt? No. So let me summarize in short how this all high availability is going to be make a sense. So whenever we talk about the high availability for any network, So you have to think about the LAN, you have to think about the WAN. Let me go in this diagram. So whenever you're going for the high availability, so you have to think for all the connections which is coming from the LAN, means this is my PC. So this PC also going to be connected via the LAN cable, and can we have the wireless NIC card also available. So in case of my LAN is going to be down for some reason, then you can switch to the wireless NIC connectivity. Some scenario even we require the dual NIC. Why dual NIC? In case, let's suppose there is a critical server hosted here. This is the S1. One NIC is going to connect with one switch and another NIC is going to connect with another switch. This kind of the deployment also it is possible. Two NIC means we can configure two different IP address and still my server is going to be accessible from that situation. So that is a NIC level, device level configuration. So high availability for switch level. In the access layer, we do not have the high availability. We can give the high availability from the uplink point of view, but downlink point of view, end devices always going to be suffer unless or until you are going to give the dual link connectivity or LAN plus WLAN connectivity. But from the upper layer, if this switch having connectivity to this one, if this is going down, still we can connect this one. So this is the your access level high availability. Clear? Now, if talk about distribution layer, this also have the connectivity with one switch, another switch. So this is getting the connectivity from the core layer. If this is going to be down, then still this is going to be get connectivity and go all communication from this way, this way, this way and this way. Whatever he want to do that, it can be possible from the core layer. And core basically we have this two switch, right? And one is going to down, still one is going to be operational. If both are going to be down, then definitely you are going to be entirely dead. There is no other way around we have. So this is the core layer. So everywhere we are going to use the two layer. Now you can think we have the firewall also here. Why two firewall? The one firewall is going to be act as active and one is going to act as a standby. So all traffic going on the internet via the active firewall, in case of this is going to be down, your standby is going to be come in picture. That is your firewall level high availability. Client level high availability, that is your FHRP, right? Where HSRP, VRRP, we are going to do that. Now, if I talk about the router, means you have the router 1 and router 2. Why there is two routers? In case of my one WAN link is going to be down, still my traffic should go via the secondary WAN link. Make sense? So we have to think always redundancy from the WAN point as well and ISP point as well. That's also very requirement, right? If I talk about the WLC, there should be also two WLC. If one is going to down, still I might be put the another WLC in this location. Just giving the example. So this WLC is going to be take a role. Might be this is my main network services, but single WLC is going to be single point of failure. Dual WLC, it is going to give the redundancy for that. Similarly, ICE, this is identity services. So ICE 1 can be deployed here, ICE 2 can be deployed here. And COCM for the voice telepresence manager, you can do that. And for the MPLS connectivity also you can do that, dual router connectivity. So for high availability guys, you have to always think how my network is going to be connected, and each layer from device to your traffic is reaching from any data center, from any location, that all should be in sync. So in case of any failure, it is going to be make the redundancy connectivity. Clear? सबको यहाँ तक?
सर एक क्वेश्चन है
Yes.
why two core switch connected each other?
Sorry?
Two core दोनों core switch each other एक केबल से कनेक्ट है.
So we talk na, we use the VSS, right? So sometimes we use the VSL link here. Logically, they're going to become one switch.
Okay.
So that's the cable, right? If you don't want to even VSL, if you want to use a separate, then you have to pass all VLANs on the trunk ports. So they have the sync of the all VLANs informations. Make sense, Karthik?
Okay.
That's why it's connected.
सर यहाँ कौन कौन सा प्रोटोकॉल हम यूज करेंगे एक्सेस पे, डिस्ट्रीब्यूशन पे और कोर पे?
So basically
Right,
on
इसको
access,
define करिए.
you just use the basically you can use the VLAN concept here, right? STP you can use that, RSTP you can use that, right? MSTP you can use that, VTP you can use that. These all protocol is going to use. Distributions आप यहाँ पे HSRP भी यूज कर सकते हो, राइट, VRRP भी यूज कर सकते हो, ENCOR भी यूज कर सकते हो, एंड ऑल्सो यू कैन रन द OSPF, BGP, EIGRP, स्टैटिक राउट, RIP, दिस ऑल पॉसिबल, क्योंकि ये जनरली L3 स्विचेज होते हैं। बट अगर ये प्योर लेयर 2 नेटवर्क है, डिस्ट्रीब्यूशन भी आपका, तो यही चीज आप यहाँ भी यूज करोगे। ट्रंकिंग का जो कॉन्सेप्ट होता है, स्विचिंग की जो आपकी VTP, RSTP, STP, MSTP, राइट, ये सारे VTP कॉन्सेप्ट, ये सारी चीजें आपको यूज होंगे। इसके अलावा कुछ और नहीं यूज कर सकते आप। स्विचिंग कॉन्सेप्ट, दैट्स ऑल। रूट गार्ड, BPDU गार्ड, ये सब चीजें आप कर सकते हो। ठीक है
सर
रुपेश?
बीटीपी तो आपका सिस्को प्रोप्राइटरी है ना?
हाँ जी, हाँ जी, सिस्को प्रोप्राइटरी।
तो उसका कोई ओपन सोर्स कोई टेक्नोलॉजी नहीं है?
.1Q तो है,
नहीं,
ट्रंकिंग
बीटीपी
प्रोटोकॉल।
बीटीपी बोल रहा हूँ, विलन ने।
विलन ट्रंकिंग प्रोटोकॉल, उसमें दो प्रोटोकॉल थे ना बेसिकली, वी हैव द ISL एंड .1Q,
ना, ट्रंकिंग में तो यूज करते हैं
राइट।
.1Q। लेकिन बीटीपी क्या होता है ना, एक स्विच मान लीजिए सर्वर बना दिया, दूसरा क्लाइंट है, तो उसमें वो
अच्छा,
विलन
आई
डेटा
कैन
चला जाता है।
क्लाइंट सर्वर एंड यू टॉकिंग अबाउट दैट, बेसिकली ये अपना ट्रांसपेरेंट मोड, राइट?
यस यस यस, उसमें तो बीटीपी जो सिस्को प्रोप्राइटरी है, हम जो सीसीएन में पढ़ा है।
राइट,
लेकिन
राइट, राइट।
ओपन सोर्स तो कोई टेक्नोलॉजी
आई
नहीं
विल
है।
चेक फॉर जूनिपर क्या उसका सब्स्टिट्यूट है, मैंने भी जूनिपर पे काम नहीं किया, बट आई विल चेक दैट, ओके।
ओके
चलो ठीक है। So I believe we are good for today, guys. Okay, let's meet on the next class, not tomorrow, day after tomorrow. All right.
ओके सर।
Thank you, guys. Bye bye. Take care.